Hi everyone. For this exercise we are going to be looking at Appendix A7 of the Francis and Garing book, and we are going to be doing an independent samples t-test. So the data that we're using is the exercise cholesterol data, and we're going to be interested in comparing the average cholesterol level for those who exercise and those who do not. So the first thing we will check is the coding for our exercise and do not exercise categories. We can do this by clicking on our variables button and then choosing our exercise level variable, and we can see that our labels correspond to the numbers 1 and 2. So 1 is does not exercise regularly and number 2 is exercises regularly. So to do our independent samples t-test, we click on Analyze, we go to Compare Means, and then we go across to Independent Samples t-test. So our test variable, the thing that we're measuring, is the blood cholesterol level. So we select that, we hit the arrow, or we drag it across into the test variable box. And our categories that we're comparing are the exercise and do not exercise. So our grouping variable is exercise level. And we need to tell SPSS what the two groups are that we are comparing. So to do this, we click on the Define Groups button. And our two groups were Group 1, which was doesn't exercise, and Group 2, which was does exercise. We click on Continue, and then we click OK. And so here's our output. We get two boxes. The first one just gives us our descriptive statistics. So we've got 43 people who do not exercise regularly. Their average blood cholesterol level is 247 with a standard deviation of 33. There's 35 people who exercise regularly, and they have an average blood cholesterol level of 189 and a standard deviation of about 35. Our second box has our test information. So the first thing that we look at is our Levine's test p-value, which is our second box here, the 0.711. And this is going to tell me whether I should be reading the top row or the bottom row, because it tells me whether or not I can assume that my variances are equal. So we look at the p-value, 0.7 is definitely much greater than 0.05. So that's telling me there's no evidence of a difference between my variances, and so for everything else I'm going to do, I'm reading the top line of information. If I had a small p-value below 0.05, that would tell me that I should use the bottom line instead. So our top line, we can come across, we've got our t-value for our report, we've got our degrees of freedom for our report, we have our p-value, and our p-value 0.000, so very, very small. Much smaller than 0.05, so that's telling me that there is a significant difference between the means. So the average blood cholesterol of those who exercise regularly and those who do not exercise regularly, I'm saying that there's a significant statistical difference between them. I can then come across further to the end where I have my confidence interval. Confidence interval tells me how big that difference is. So 42.91 through to 74.277, that is how big the difference. So the average blood cholesterol of those who do not exercise regularly is between 42.9 and 74.3 units higher than those who do exercise regularly.